In example 2, again, it's in function notation. However, this time when we look at that graph, it's just a bunch of lines put together. We have no idea what that original equation was. We want to graph y equals g of 0.5x. That 0.5x is inside the function. So right away, we know it's going to be horizontal. The question is it a stretch or is it a compression? Well, we would multiply x by maybe this is even easier to think of if you change that half to a fraction. I like fractions so much better than decimals, just because I feel like there's so much more you can do with them. When you see that 0.5, it's not easy to do the reciprocal of 0.5, but when you think of the fraction of 1/2, it's easy to flip it and do 2 over 1. So if we're multiplying x by 2, we would say that this is a horizontal stretch. What are the points we have on our original graph? Well, we have -3, 2, 1, 5, 3, 3, and 4, -2. So if we use the same strategy we did last time where we wrote down our original points, -3, 2, 1, 5, 3, 3, and 4, -2, and we say in this transformation we need to multiply our x values by 2, what's going to happen to each one of these points? Well, -3, 2 is going to become -6, 2. 1, 5, 2, 5. 3, 3, 6, 3, and finally 4, -2, 8, -2. I'm going to warn you right now. Multiplying by 2 is easy. Why is that a warning? Your brain will tell you this is easy. And because it tells you this is easy, it tells you, you know what? You can do that. Start thinking about the next thing you should do. And as soon as you start thinking about the next thing you should do, chances are somewhere in here, you're going to multiply the wrong number by 2. You're going to multiply, instead of 1, 5, you're going to write, oh, multiply by 2, 1, 10. Your brain's going to be like happy. Yeah, multiplying by 2 is easy. But we have to make sure sometimes we don't try to think too far ahead because it's so easy to make those little mental math errors here. So I'm going to just double check. Yes, I multiplied all of my x coordinates by 2. A horizontal stretch. Yes, it would be -1 and 5, right? Writing down points is easy too. I was already thinking about the next thing. Good. So we have -1 and 5 and -1 and 5. Whew. Luckily that didn't mess things up too much. But this is where you're always sort of doing checks along the way. I don't always say what goes through my mind, probably a good thing, but I'm always checking things as I go. Now the fact that -1, 5, okay, had we not noticed it then, when we go to plot these points, I would have had -6, 2. 4, 6, -6, 2. I would have had 6, 3. I would have had 8, -2. And then this one would have been over here instead of over this way. So I would have realized, hey, something looks wrong here. Because in the end, when we join the dots to this blue graph, it's supposed to look, a horizontal stretch means you grabbed a hold of it and pulled it away from the y-axis. So you might notice one of your points is off at that time, which would have told you, hey, I missed that negative. but most likely you're going to do a mistake like that. Writing down points, labeling points is easy. So it's super easy to make a mistake because your brain will tell you, you can think about the next thing. Okay? And most of our mistakes, a lot of mistakes you make in math are on those easy things because you just don't pay attention for a second. And then you get frustrated at the end because your answer is completely wrong. You're like, what did I do? Do I know nothing about math? The answer is usually no. You know lots about math. You just made a silly mistake or a simple mistake along the way. Okay, read the question again. State the domain and range. For our red one, this time I will use set notation. My smallest value is -3, less than or equal to x. In my red graph, my biggest value is 4. And my range, my smallest value is -2, less than or equal to y, less than or equal to largest y value is 5. On my blue graph, first of all, I'm going to do the range. Because we multiplied our x values by 2, our range is not going to change because it's y values. But now when we look at our x values, our smallest x value was -3. Now our smallest x value is -6. And our biggest x value is 4, and now it is 8. Try questions 4 and 8.